Good morning, everyone. I am Caleb Emmanuel Frias, and I am from STEM12A. And today, I'm gonna show you how to solve some electric charge and field problems. First problem: 2-point charges are separated by 25 centimeters. Find the net electric field these charges would produce at point A and B, and what would be the magnitude and direction of the electric force this combination of charges would produce on a proton at point A. So, first, find the electric field at point A. So we're gonna be using the formula as you can see at the top right in order to find the electric field. And at the bottom right, you can see the free body diagram, and that which shows the two forces that oppose the two electric field forces, and they also show that they oppose each other. That's why in the formula, in finding the net electric field at point A, we're gonna be subtracting both of them. So by substituting these values into the formula and inputting it into your calculator, you're gonna get 1.0 times 10 raised to 4 newtons per coulomb. Next problem, find electric field at point P. As you can see at the free body diagram, the two forces are moving in harmony with each other. That's why at the net electric field, we're gonna be adding both of them instead of minusing them, in contrast to what happened at problem A. So by substituting the values to the formula and inputting it into your calculator, you're gonna get 7.4 times 10 raised to 3 newtons per coulomb. Find magnitude and direction of the electric force on a proton at A. In here, we're gonna get what we got from problem A, which is 1.0 times 10 raised to 4 newtons per coulomb, and multiplying it by the charge of the proton, which is 1.6 times 10 negative 9 times 10 raised to negative 19 coulombs, in order to get the force or the magnitude. So by doing that, we get 1.6 times 10 raised to negative 15 newtons, and we know that it goes to the right because attraction force of the charge of the right to the right side of the proton is greater than the attraction force produced by the charge at the left side of the proton. Second problem. Point charge Q1 is equals to 5 nanocoulombs is at the region, and point charge Q2 is equals to 3 nanocoulombs, and it's on the x-axis at x equals to 3 centimeters. Point P is on the y-axis at y equals to 4 centimeters. A. Calculate the electric fields E and E at point P due to the charges Q1 and Q2. Express your results in terms of unit vectors. Use the results of part A to obtain the resultant field at P, expressed in unit vector form. So first, find the electric fields E and E at point P due to the charges Q1 and Q2. As you can see at the top right, that's the visual representation of the problem given to you earlier. And as usual, we're going to use the formula at the bottom right, as you can see, in order to find the electric fields. So first of all, we're going to find the unit vector of the two charges. So for the Q1, the we're going to use R1 hat, and for Q2, we're going to use R2 hat for the unit vector. And so for R1 hat, we get 0 I hat plus 1 j hat as the unit vector, and for charge 2 or Q2, we get 0.6 I hat plus 0.8 j hat. By substituting the given values to the formula, we get for the first charge or Q1, we get 0 I hat plus negative 2.8 times 10 raised to 4 newtons per coulomb j hat. And for charge 2, we get, or Q2, we get 6.6 times 10 raised to 3 newtons per coulomb I hat plus 8.8 times 10 raised to 3 newtons per coulomb j hat. And in order to get the resultant field at point P, we simply just add the two values, and therefore we get 6.6 times 10 raised to 3 newtons per coulomb I hat plus negative 1.9 times 10 raised to 4 newtons per coulomb J hat. For the last problem, if two electrons are each 1.5 times 10 raised to negative 10 meters from a proton, find the magnitude and direction of the net electric force they will exert on the proton. So first, we're gonna visualize the problem. As you can see at the free body diagram, there is one force going upward, which is from the second charge, and also Q1 and Q2 also acts to the right side, and also they act in harmony. So in problem A, find the magnitude and direction of the net electric force on the proton. So we're gonna divide the net force into the two components, the x and the y component, and as usual, we're gonna use the electric field formula, and then we multiply it by the charge of the proton in order to get the magnitude at that certain component. So we do that for both the x and the y components, and in order to get the magnitude or the net force, we simply use the Pythagorean theorem. Therefore, we get 1.7 times 10 raised to negative 8 newtons. And in order to get the angle, we simply use Sakatowa, in which case we use arctan times opposite over adjacent, which is 9.3 times 10 raised to negative 9 over 1.5 times 10 raised to negative 8, which will equal to 32 degrees. That's all, and thank you for watching.